Hi everybody, and welcome to take 2 of this particular flipped classroom lesson. I'm trying to record this on a different computer, so cross your fingers that you can actually hear it this time. So we already talked about steps 1 and 2 of the scientific method. We talked about step 1, which is writing a good testable scientific question, and step 2, which is writing a good if-then-because hypothesis. So step 3 is to design an experiment. We've got a question, we've got a hypothesis, now we need to do the experiment to test it. Now, what makes a good experiment? Control. You need to have a controlled experiment. And when I say control, I mean you change only one variable at a time. Only one thing can change at a time. If you change more than one thing, more than one variable, you're not really going to know what affects the change in the end, and it's going to be an inconclusive experiment that doesn't really tell you anything. Okay, now what do I mean by variables? What is this word variables? It has a lot of different meanings depending on what context you're using it. In science, a variable are the things you change, control, and are looking for in an experiment. A variable is basically anything that can affect what happens in your experiment. Now, there are 3 types of variables. The first one is a controlled variable, and these are the things that never change from one trial to the next. This would be like type of equipment. So if you use one type of thermometer in the first trial, you're going to use it in every single trial. Or if you use one type of heater, you're always going to use the same type of heater. Also, some things like time. So if you do the experiment the first time for 30 minutes, the next trial also needs to be 30 minutes. These are things that affect your experiment and are always going to be the same. They're called controlled variables because this is what makes sure that your experiment is controlled, which is what makes a good experiment. Now, the second type of variable that you need to know about is an independent variable. And this is what you change in the experiment. It's what you, as the scientist, are in charge of. So here's a hypothesis kind of based off that model volcano thing that we were doing last week. So if I put more vinegar into my model volcano, then it will have a bigger eruption because the vinegar will create more bubbles. The independent variable, what you were controlling, what you are controlling is the amount of vinegar, this part right here. You are in charge of that. You will put maybe, let's say, 1 tablespoon of vinegar in this time, and then 2 tablespoons, and then 3 tablespoons. It's what you as the scientist are changing. That is your independent variable. Now, the next and last kind is called a dependent variable, and it's what you're looking for in the experiment. What are you testing? What are you measuring? So back to the exact same hypothesis, you are looking for the bigger eruption. So the size of the eruption is what you're looking for, and this is going to be your dependent variable. Independent is what you as a scientist changed. Dependent is what you are testing, what you are looking for. Now, the 4th step of the scientific method is to collect data. What's the point of doing an experiment if you don't collect any data? Then you're just, blowing things up for the heck of it and not learning anything from it. Okay, so it needs to be organized and it needs to be consistent. So you want to collect your data in the same way throughout your entire experiment, and you want to make sure that it's easily readable. So typically you're going to organize this in like a table or a chart. Also, typically in the type of science that we're going to be doing this year, you want quantitative data. That's a really big long word for numbers. Okay, data is information, any type of information. And the information that we need typically in science is going to be numerical or numbers. So that way we can make graphs and charts and conclusions and comparisons and all sorts of things like that. All right, ladies and gentlemen, make sure that you have completed your notes, written a summary at the end, and have a question for me in class tomorrow. Thank you so very much.